This video is going to hit learning target 5. I can transform a quadratic from standard to vertex form. This is also known as completing the square. And this is actually going to be broken up into 3 parts. The first part is forcing perfect squares. Part 2 is completing the square to solve. And then part 3 is completing the square to transform standard to vertex form. And so that last part means we're going to go from ax squared plus bx plus c, and we're going to transform it to a times the quantity x minus h squared plus k. Note, transform, one of your command terms, means you algebraically work with the given equation to change it into the other form. Some of you may find a shortcut to go from standard to vertex form, but I will let you guys think about that. So we're going to start with part 1. And in order to complete the square, we're going to have to know some definitions. So a perfect square trinomial is an algebraic expression with 3 terms that are created by squaring a binomial. Some examples. X squared minus 8x plus 16 is a perfect square trinomial because it comes from x minus 4 squared. X minus 4 times x minus 4 will give you x squared minus 8x plus 16. Here's another example. In general, a plus b quantity squared is a squared plus 2ab plus b squared. And so notice the middle term is twice the product of a and b. So we're going to use that fact to be able to force a perfect square. So find the value that completes the square and then rewrite as a perfect square. So x squared minus 30x plus, what would make a perfect square trinomial? Well, we know that a plus b quantity squared is a squared plus 2ab plus b squared. And so minus 30x is this middle term. And so I'm going to cut negative 30 in half. That's going to give me negative 15. This is going to be my b value because my a value is 1x, right? Because x squared is the same as a squared. And so to complete the square, I'm going to square negative 15, and that will be 225. Which means that the perfect square binomial would be x minus 15. Notice this number squared. This number comes from half of the middle term. Again, this works because a is 1 in our x squared term here. So number 2, we're going to repeat the process. We're going to cut 36 in half, so that gives us 18, and we're going to square it. 18 squared is 324. Try the remainder on your own. Pause the video and then see if you are good with forcing completion of the square. So x squared minus 9x, I'm going to cut the middle term in half. So that's negative 9 over 2. And now I square that and I get 81 over 4. A squared plus 3/4 a plus, to force a perfect square, I'm going to cut the middle term in half. That becomes 3/8. Square it, and I get 9 over 64. That's my b squared term. For number 5, we're going to divide the middle term in half. So I'm going to do negative 1/2 divided by 2. So that becomes negative 1/4 squared. And so this becomes 1/16. This one I'm going to work opposite. This is m squared plus something plus 16. Well, what did I square to get 16? Well, that must be 4. Would be 4, and then I need to multiply by 2. So that becomes 8m. Negative 9/2 divided by 2 is negative 9/4. Negative 9/4 squared is 81 over 16. A squared minus 10a, divide negative 10a by 2. That gives me negative 5. Square it, and I get plus 25. Now, to write them as the binomial, I'm just going to take what I divided by 2, and that goes inside my parentheses. So I divided 36 by 2, that gives me a plus 18. So this is plus 18 squared. I squared negative 9 halves to get my 81 over 4, and so this is the same as x minus 9 halves squared. I squared 3/8 to get 9 over 64, so this binomial is a plus 3/8 squared. I squared 1/4, negative 1/4 to get 1/16, so this becomes x minus 1/4 squared. This one, I squared 4 to get 16, and so this would be m plus 4 squared. I squared negative 9/4 to get 81 over 16. This would be x minus 9/4 squared. And lastly, I squared negative 5 to get positive 25, and so this would be a minus 5 squared. And again, we can expand each of these, and we will get our result of our perfect square trinomial.